Hello everyone, welcome to My Chem Corner. So in today's class we're going to learn about one important mechanism from chapter 11, alcohols, phenols and ether. Now this is a very important mechanism from the chapter. Since it contains three different steps, we're going to see how the mechanism is done in three different steps with electron transfers and product formation. Alright, so today we are going to learn acid catalyzed dehydration of ethanol to ethene. Now this is going to be a basic conversion of ethanol to ethene, which is an alcohol to alkene. But what do you mean by acid catalyzed dehydration? Let's break down these words. Dehydration meaning removal of water molecule. Say for example, you are in a race or something like that, and after a long race you are dehydrated. Meaning what? You need water. Your body is not containing enough amount of water. You get tired, right? So that is your dehydration. The same meaning here. Dehydration meaning you're going to remove water molecule. Now, what do you mean by acid catalyzed? The term catalyzed or a catalyst itself means, you know the term, the definition of a catalyst, something that is going to help a reaction move forward without getting used up in the reaction. Alright, when I say acid catalyst, here acid or H plus is what is going to be used as a catalyst. So which means say that you use the acid in the first step and then the acid is removed in the last step. Okay, so that is what your entire mechanism is all about. So let's see what the basic equation is. So here we have ethanol, which is CH3, CH2, OH. This is going to react with H plus, which is the acid. This is going to form ethene, which is CH2 double bond CH2. So this is the reaction, the final reaction for which we are going to put down the mechanism. Now, if you are studying for PUC, this is going to be a proper 3-mark question from the chapter, which is there as a compulsory question. All right. Now, let's move into mechanism. Now, under mechanism, we are going to write this stepwise and not all together. So, we are going to write step 1. Under step 1, it is going to be protonation of alcohol. What do I mean by this term? Protonation of alcohol. I have the alcohol. I'm going to introduce a proton to it. That's what protonation of alcohol is. So when I'm trying to write this, I have CH3, CH2, OH. Now for this you're going to have a double-headed arrow and this is going to be treated with H+. Now what happens here is oxygen has 2 lone pairs of electrons. So here, because oxygen has a lone pair, this lone pair is going to bond with H+. Now what happens here? Oxygen has lost a lone pair and therefore oxygen will acquire a positive charge. So I'll get CH3, CH2. This hydrogen is already there. This one next to hydrogen is a newly formed hydrogen from the acid. Now oxygen will get a positive charge because oxygen has lost a lone pair. Alright, so your alcohol is protonated. Now next step is you are going to form water. So what you're going to do, this is going to be removal of water molecule. Alright, removal of water molecules. I'm going to take the product from the first step, that is CH3, CH2, O with both the hydrogens and a positive charge. Now here what will happen? What's going to happen here? In this case, if I can't break the hydrogen bonds because they are newly formed, you can only break the carbon-oxygen bond. So here the arrow will move towards the oxygen atom, and when it moves towards oxygen atom, what will happen there? In this case, the carbon has lost an electron. So here carbon will carry a positive charge because the electron movement is towards water. So I'll form H2O here. Next one, the last step is going to be step 3, which is removal of H plus. Now removal of H plus, as I've told you, since it's an acid catalyzed reaction, the acid is used in the first step and it's removed in the last step. So here I'll just write it this side. I'm going to just expand the entire product that is there in the previous step so that you know how the bond breakage is taking place. This is the positive charge here, that is the last step. Now what will happen here is that there's nothing else in the reactant side, alright, but you need to remove a H plus. So what happens here, it's just a simple hydrocarbon with a carbocation. So here you are going to do is hyperconjugation, okay. You will take from the adjacent carbon a bond from there by removing hydrogen. So here what happens is the next carbon that is next to the carbocation will break a carbon-hydrogen bond and it will form a double bond. So when you are trying to form bond here, what will happen? I have carbon with 2 hydrogens already, so I'm putting CH2. It was initially single bonded and then a CH2 here. Now since the bond is broken, I am going to get a double bond over here. So that I'm going to form ethene and I'm going to remove a H plus. So H plus is introduced in the first step and it is removed in the last step. Now this is going to be the entire mechanism for an acid catalyzed dehydration of ethanol to ethene. So first step is going to be protonation of alcohol. The second step is going to be removal of water molecule and the third step is going to be removal of a proton. For PUC students of second year, this is a sure 3-mark question asked in the PUC board exam. Alright.